Hi, welcome back to PSLE Math Concept Lessons. Now, today we are going to look at properties of angles, which are triangles. Right, properties of angles in triangles. So it's going to be an easy lesson. So how to do well for this topic? It is to able to understand the properties and also to remember. Right, remember all the properties that you will see over here. And once you can do that, you should be able to score well for this topic. So let's look at the first property. Now, the first very common property is angle on a straight line, which means that if you have a straight line, every time you see a straight line and there's an angle, right angle on the straight line, then the angle is 180 degrees. So let's look at question number 1. So how do I find angle COD? Now, you have to recognize what is angle COD. So where is the angle? So you start from C, O, D. So you can see there are two lines, right? Two red lines. So the angle is between the two lines, and that's what you're supposed to find. And if you see a square box, that is a right angle. And there is a straight line. So in all your pictures, right, in all your questions on angles, you will always have straight lines. And so the angle on the straight line, which means that all the angles add together is 180, and you minus 45, and you minus 90, and you will get 45 degrees. So the angle over here is 45 degrees. Okay, let's go to another example. Alright, now again there's a straight line, so always look out for straight lines, and the straight lines must be indicated by the question, because sometimes the question may not say it's a straight line, but it looks like a straight line. However, you cannot assume, right? Unless the question says, you cannot assume it's a straight line. So AB is a straight line, so which means that this whole angle is 180. So how do you find angle EOF? So you must be able to recognize the angle. Where is the angle? EOF. So the angle is between the two red lines. So you take 180 and you minus 36 and you minus 82 to get the angle EOF. So what is that? 180 minus 36 minus 82, and you will get 62 degrees. So angle EOF is 62 degrees, which is over here. Alright, so it's actually quite easy to use this property. Okay, so we have the first property already. So now let's go to the second property. Now, angles at the point, what does that mean? It means that if you see a circle, or if you see the angles form like a circle, then all the angles add together is 160 degrees. So if you look at the picture over here, you can see that all the angles, they actually look like a circle when you join them together, right? So when you see something like that, it means that you have to add up all the angles, and the total is 360 degrees. So to find angle X, you have to take 360, which is angle at the points, minus 100, and then also minus 120, and that will give you angle X. And so what's angle X? So you minus 100 minus 120, and you get angle X, which is 140 degrees. Okay, and that's how you solve. Alright, so so this property is also very common. So look out for angles that form a complete circle, and once you see that, then angles at the point add together is 360 degrees. Okay, let's look at another example. Again, you look at the angles. They form like a circle. So how to find angle A? So angle A will be equal to angle at a point, or the angles added together, is 360 minus 127 and minus 93 and minus 25. So what do you get? 360 minus 127 minus 93 and minus 25, and your answer will be 115 degrees. Now, is there any way to check whether your answer is correct? Well, there is a very good way. You look at the angle size, right? The size of the angle that you're asked to find. You can see that it is an obtuse angle. What is an obtuse angle? Angle that is more than 90 degrees. So if your answer is less than 90, then you will know that your answer is wrong, because this is an obtuse angle that you are finding. So your number must be more than 90, right? So that's how you check whether your answer is correct, by looking at the size of the angle, whether is it obtuse, whether is it acute, or whether it's a reflex angle. Alright, okay, so let's go on to the next one. Alright, next one, you have another property. So this time you look for special letters, right? X. So when you see two lines that form an X, then you have vertically opposite angles which are equal. Like for example, you have three straight lines. Okay, so before we look at this problem, let's look at what do you mean by X. Now if you see two lines that form a cross, then this angle and this angle, they are vertically opposite, right? And they will be the same, equal. And then of course this angle and the other angle are also vertically opposite, so they are also the same. Okay, so once you understand that, we can do the question 1. So where is angle COF? So you need to use your highlighter or something to trace the angle COF. So the angle is over here. Alright, that's what you are asked to find. Alright, now can you see two lines? If you notice carefully, there are two lines that form a cross. Alright, so immediately this is 78, then the other angle must also be equal. So your angle COF is 78 degrees. Okay, alright, how about your AOF? So let's use a different color. So your AOF is here, AOF. Alright, so it means that you're asked to find this angle, right? Okay, so how do you find this angle? Well, can you see another two lines? If I use green color, you can see two lines that form X. So which means that your AOF must be the same as these two angles add together, which is 78 plus 25 degrees. So angle AOF is equal to 78 plus 25 degrees, and you will get 103 degrees. So how do you know whether your answer is correct? You look at the size of the angle, which is bigger than the right angle, right? This angle that you're asked to find is an obtuse angle, so your answer will have to be bigger than 90 degrees, right? And that's how you check whether your answer is correct. So look for two lines that form a cross, and then you have vertically opposite angles. So in other words, look for X, right? A special letter. Okay, let's go to the next one. All right, now when you see triangles, right, then what happens? The sum of angles in a triangle is 180 degrees. So where are the angles in the triangle? You look for the angles that are at the corners of the triangle. So later on, for harder problems, you will see many angles in the same triangle. But which angles belong to the triangles? The angles that are at the corners of the triangle, they are the ones that belongs to the triangle. Okay, and when you add them all together, what happened? Then the sum is 180 degrees. So which means that you take 180. Alright, and by the way, you're supposed to find angle ACB. So in your school, you will need to label the letter, right? So that the teacher can understand what angle or can recognize what angles you're finding. So angle ACB is equal to sum of angles in a triangle minus 63 and minus 72. And you work out. So 180 minus 63 minus 72, and you will get 45 degrees. So angle ACB is 45 degrees. So a very easy property, which is sum of angles in a triangle. In other words, if you see a triangle, then the angles at the corners, the three corners, they will add together become 180. So important lesson. For very hard problems, you have many angles all over the picture. But how do you know which angles belong to the triangle? You always look for the corners of the triangle. Okay, look for the corners, the three corners, and the angles at the corners, they will belong to the triangle. And when you add them together, they will be 180 degrees. Okay, let's go to another example. Like over here, you can see there are many angles here, right? And there are a few triangles. So what is angle ABC? Okay, now if you look at this triangle, right? So you learn to break up the whole figure one triangle at a time. Like in this whole figure, there are a few triangles. So if I want to find, for example, angle A, I look at this particular triangle. I look at this triangle. And where are the angles that belong to this triangle? The angles, they are near the corners. Alright? So these angles, they add together is 180. So my angle A will be 180 minus 45 and minus 50. So what's angle A? And so you minus 45 minus 50, and you will get 85 degrees. And whatever numbers you have found is always important to put it inside the picture. Alright? Okay, and then what else can I find? Now, then you apply whatever you learned just now. Like, do you see a straight line? But the question never say it's a straight line. But because it's a triangle, so triangles are made of three straight lines. So you will definitely have a straight line here because it's one side of a triangle. So as a result, you have angle on the straight line is 180 degrees. So which means that to find angle C, I have to take 180 minus 85 to get 95 degrees. And you can see that the angle is obtuse, right? It is bigger than the right angle, so your number must be more than 90 degrees, right? So your angle C is 95 degrees. Alright, now how to find angle B? So again, look at this triangle. So you have to focus on one triangle at a time, so that you can work out the answer one by one. So this blue triangle, where are the angles that belong to this blue triangle? The angles at the corners. So look for the corners of the triangle. So these three angles will add together, become 180 degrees. So angle B is equal to 180 minus 38 and minus 95. And you will get angle B. So 180 minus 38 and minus 95. And you will get 47 degrees. And that is your angle B. And that's how you get ABC, right? Angle ABC. Alright, so it's not that very hard, it's actually quite easy. If you know your properties and you remember your properties, it is actually easy to do quite well, right? Quite well for this topic. Okay, now let's go on to the next question, alright, the next property. Okay, now you have right angle triangles. So you have few kinds of triangles. You have normal triangles, like what you saw just now, and then you have a right angle triangle, which is very easy to recognize by the square box. Right, we see a square box that is 90 degrees. And then you can find BAC. So where is BAC? So the angle is between the two lines. That's what you're asked to find. So angle BAC is equal to sum of angles in the triangle, which is this triangle. Alright, so where are the angles in this triangle? Look for the corners of the triangle, right? And that will be 180 minus 90 minus 42, and angle BAC is 48 degrees, right? So remember to look for the corners. Look for the corners of the triangle. That is where you have the angles that will add together become 180 degrees. Okay, let's go to another example. Again, you have a few triangles. How many triangles do you see in this picture? It is not two triangles, it's actually three triangles. Alright, so how do you find angle A and B? Well, if this is a right angle, because it's a square box, there's a square box there. So there is one triangle over here, and that is your right angle triangle. And where are the angles that belong to this right angle triangle? The angles near the corners. So can you find angle A? Yes. Angle A is equal to sum of angles in the triangle minus 90 and minus 55. And you will get 35 degrees. So angle A is 35 degrees. Okay, where is the other triangle? Well, the other triangle is over here. Alright, there's another right angle triangle. But how do you know it's a right angle triangle? Because angle on the straight line is 180. Remember, this is a straight line because it's one side of a triangle. So angle on the straight line is 180. So 180 and you minus right angle gives you another right angle, which is over here. So you have another right angle. And now can you find angle B? So angle B will be, look for the angles near the corners, right? The corners of the red triangle, and you add them all together, that will give you 180 degrees. So 180 minus your 90 minus your 50, that will give you angle B, which is 40. Right? So are there two triangles or are there three triangles? Well, there are three triangles because there is one very big one. Okay, there's a one very big triangle over here. So you actually have three triangles. Okay, so you can see it's quite easy, right? So right angle, if you see a right angle triangle, how do you recognize that? If there's a square box or if the question says so, then that is a right angle triangle. Okay, let's move on to another property. So now you have isosceles triangle. So what do you mean by isosceles? It means that two sides of the triangle are equal. So for example, if you read the triangle, read the question, AB is equal to AC. So there are two markings here, all right? So it tells you that this side and this side, they are the same. They are equal length, right? They are the same length. All right. Now because of that, there must be two angles which are also equal. Now pupils have a very or there's a very common mistake that students will make. They cannot recognize which two angles are equal in the isosceles triangle. They always get it confused. So how do you not get confused? How do you know which two angles are equal? It's very easy. Now you just put your fingers, all right, put your fingers at the meeting point. The meeting point of the two lines that are equal, and then use your fingers. One finger trace one line, the other finger trace the other line, and move your fingers downwards all the way to the end of the two lines. And the angles that are at the end of the two lines will be equal. And this angle is 76. So what's the helping hand here? Now you put your fingers at the meeting point of the two lines, and then use your fingers to trace, to follow, right? Follow the two lines. Like for example, your fingers go down this line until you come to the end. Then the other finger at the same time also go down this line. And once your fingers stop at the end of the line, then the angles at the end of the line, they are equal. All right. So that's how you recognize which two angles are the same. So what is angle BAC? So angle BAC, which is this angle, and how to do that? You take sum of angles in the isosceles triangle. So you have to recall your earlier properties to continue doing this. So 180 minus the two equal angles. So minus 76 and minus 76. So what do you get? So 180 minus 76, and you will get 28 degrees. So angle BAC is 28 degrees, right? Okay, another example. Now, you have a right angle triangle, right, because the question says so. And not only that, your JK is equal to KL. Now, when you see this kind of phrasing, it means that you have two equal sides. So this side and this side are equal, and they are indicated by the markings, right? There's a two markings here. All right, so which two angles are equal? Now you take your finger, right? Can you see these two lines are equal, right? These two sides. First of all is to recognize which two sides are equal. All right, then you highlight. Okay, you highlight the two sides that are equal. Then put your fingers, right? Your two fingers, and put them at the meeting point here, right? Meeting point. And then one finger trace the red line to the end. The other finger trace the red line to the end. And where your fingers stop is where the angles are. And these two angles are equal. Okay, and that's how you recognize which two angles are the same. Alright, so how do you find each of these two angles, which is your KJL, right? This angle, how to find this angle? Now, you take sum of angles, right? Angle KJL is equal to sum of angles in the isosceles triangle, and you minus your right angle, which is 90, alright? And then all you have to do is just take the answer and then divide by 2. And you will get 45 degrees. So which means that this is 45 and this is also 45 degrees. And that's how you find each of these two angles that are the same. Alright? Okay, another example. Okay, one more example. You have triangle WXY is a right angle triangle. So once you see the word right angle, then this is your 90 degrees. And WX is equal to XY. So you have two sides that are equal. So they are indicated by the markings here. So you may want to highlight. So your WX is over here. This is this side, and your XY is this side, and they are the same. Alright, then which two angles are equal? Then you take your fingers. Alright, if you are still not clear or you're confused, take your fingers, put at the meeting point. Right, put your two fingers at the meeting point of the two lines, and then trace one line, trace the line all the way to the end. Okay, let me just draw a bit nicely. Okay, so trace the line with your finger until you come here. All right, and then the angle will be this whole angle, right? This angle. Why this angle? Because remember, right? This is an isosceles triangle. So the angle, which angle belongs to the isosceles triangle? The one that is at the corners, right? The angle that's at the corners belongs to the isosceles triangle. All right, so this angle will be the same as which other angle? Then you take your finger and trace the other red line towards the end. All right. Okay, let me use a different color. Okay, so that you can see more clearly. Just now, what did we do? We trace the red line all the way to the end, and this is the angle that will be the same as trace your finger on the other red line until the end, and will be the same as this angle. Right, so which means that these two angles, they will be equal. So how do you find these two angles? How do you do that? Now you take, okay, let's write down angle. Now when you work out your steps, every step need to have labels. So for example, if I want to find this angle, what do I call this angle? XWY. So angle XWY is equal to sum of angles in the isosceles triangle, right? And then you minus your right angle, which is 90, which is over here, and then you divide by 2, and you will get 45. And whatever numbers you found, you have to put inside 45. And if it's too squeezy, right, too cramped, then you put the number outside so that you don't distort the picture. Right? Don't put too many numbers if you find that it's a bit messy. Otherwise, you can't see clearly. So any numbers that has no space to put inside, you can put outside. Okay, now I want to find ZYW. So where is ZYW? Which is over here. Okay, ZYW. Alright, so this angle, right? I want to find this angle. So how do I find this? How do I find this angle? Okay, now there are a few ways you can do that. Alright, well, let's look at one of the ways. Now, can you find this angle here? Right, there's an angle, the angle there. So how do you find the angle? If you notice carefully, there is triangle. There is a smaller triangle here. Alright, so look out for triangles. And then the angles at the corners will add together become 180. So what angle do you want to call that? Or what angle you're finding? That will be XYZ. So angle XYZ is equal to sum of angles in the triangle minus 90 minus 74, and you will get 16. And then whatever numbers you found, put it inside 16. Alright, so now can you find the question mark? Yes, I can, because you take the bigger angle, which is 45 degrees, and you minus the smaller angle, that is 16, and you get the other angle, which is 29 degrees. Right? Of course, you have to label your steps. So what angle are you finding? ZYW. So angle ZYW is equal to 45 minus 16, and you get 29 degrees. So how to get your method marks is when you show your steps clearly, and you also need to label. Well, in some schools, your teacher may not ask you to label, but I will prefer you to label so that it's easier for your teacher to understand which angles are you finding. Okay, so that's how you do this, and let's look at one last one. Okay, so now we look at equilateral triangle, which is a very simple triangle to recognize. As long as the question says the triangle is equilateral, then what does that mean? It means that all sides are equal, right? All the three sides will be the same, and all the angles at the corners will also be the same. So you take 180. Why? Because the sum of angles at the corners add together is 180, right? And divide by 3, because all the three angles are equal, and you will get 60 degrees at every corner. 60, 60, and 60. So your angle C is 60 degrees. Okay, so that's how you recognize equilateral triangle, if all the three sides are equal. Okay, now DEF is an equilateral triangle. So what I would like to do is, every time is a complicated question, or if the picture looks very complicated, then I may want to use some highlighting, right? I may want to use some colors to show out the equilateral triangle, which means that the angles at the corner is 60, here 60, and here will be 60. So maybe I would like to put the number outside so that we don't get confused by too many drawings. Okay, so where is angle EDF? So your angle EDF is over here, E, D, and F. Oh, not F. Okay, that's not F. Okay, one more time. EDG, right? Oh, EDG, not EDF. So E, D, and G. So this is the angle that you are supposed to find. Alright, so how do we find the angle? Well, it's actually quite easy. So you can see that this is a straight line, but the question number says, but because that line is one of the sides of the triangle, and triangle has all sides which are straight lines, right? Three sides, they are straight lines. So this angle is a straight line. If this is 87, you can find the other angle. So what's the other angle? What do you call it? You call it E, angle E, G, D. And angle on the straight line minus 87, and you will get 93. So this angle here is 93 degrees. Alright, so now you can find the question mark. So what is the question mark? Which is your angle EDG. Alright, so what angle is that? Again, you see there's a red triangle, right? So every time you see a triangle, what does it tell you? The sum of angles in the triangle add together, and where are the angles? The angles at the corners, they add together is 180. So 180 minus 60 minus 93, and you get the question mark. So 180 minus 60 minus 93, and you will get 27 degrees. So your angle EDG is 27 degrees. Okay, right, so for angle problem, you may want to use some color pencil to show out what kind of triangles they are. Okay, next one. Gets maybe a little harder. Now, triangle DEF is an equilateral triangle. So where is your DEF, which is the bigger triangle that you see? Alright, so this is your equilateral triangle. So let me use a red color to show out the equilateral triangle. And what do I know about equilateral triangle? The angles at the corners, they are all the same, which means that 60, and then this angle here will be 60, and then this angle here will also be 60. Okay, and then you have a triangle that is isosceles, which is your EFG, is an isosceles triangle. Alright, so where's your EFG? The blue triangle. Alright, this is an isosceles triangle. So which two sides are equal? Now you can see the markings, the two markings are here. It means that these two sides are equal. So which two angles are equal? You take your finger, put at the meeting point of the two lines that are equal, and one finger move down, trace the line to the end. Right, trace the line all the way to the end, and there's an angle at the end here. And then use the other finger, trace to the end of the blue line that's equal, and there's an angle here at the end of the line. So these two angles will be equal. So you have two angles that are the same. Alright, they are the same because it's an isosceles triangle. Alright, so how do we find out what is each of these two angles? Okay, for example, I want to know this angle. Right, what do I call this angle? So angle GFE. Alright, so every angle that you want to find, you have to label what is the name of the angle. So GFE is equal to sum of angles in the isosceles triangle, right, which is 180 minus 108. Right, you can see there's a 108 here, and then take the answer, divide by 2. So every time you want to find each of the two equal angles, you divide by 2, and you will get 36. Okay, so which means that this angle here is 36, and this angle here is also 36. Okay, so now can you find angle DEG? So where is your angle DEG? So D, okay, let me use my green color, DEG. Can you see the, okay, or let me just draw a bit nicely. Okay, one more time, DEG. So the angle that you want to find is over here, right, the green color. Okay, the green color angle. So how do you find that green color angle? You can see there's a bigger angle, which is 60 degrees. That's a bigger angle, and you minus the smaller angle, which is 36 degrees. And you get the other angle, which is your DEG. So need to label. DEG is equal to 60 minus 36, and that's how you get 24 degrees. And whatever numbers you found, it is important that you put inside, because when you put more numbers inside, it becomes clearer to find other numbers later. Alright, so so that's the end of our properties of angles in the triangle. So of course, there's still another lesson on angles, which is the properties of angles in quadrilaterals, right? In 4 other figures. But for this lesson, we are only looking at triangles. But you will need to remember all these properties, which are very simple. So once you remember the properties, then you will have to know how to apply the properties, right? So and how to apply, that's where you need to practice. You need to do questions on angles and look at the pictures and see how to apply the properties. Alright, and that's how you do better for this topic. Okay, so we come to the end of this PSLE Math Concept Lessons. So stay tuned for the next lesson, which is your angles part 2. Alright, and then after that we will do other topics for Primary 5. Alright, so see you in the next lesson.